In the previous video, we covered a lot of theory about OpenCL. Now it's time to get practical.
Welcome to CompilerSutra.
Hello and welcome. In today's video, we will walk through the folder structure of basic OpenCL project, something every GPU programming beginner should understand before diving deeper. We will keep it simple, step by step and crystal clear. Let's begin. Before jumping into folders, let's quickly define what we want to achieve. We are going to run a simple OpenCL kernel that adds two arrays A and B and store the result in C. This is the classic hello world of GPU programming. It's powerful enough to help us understand how a GPU executes parallel code. This is where our OpenCL kernel lies, the CL file that actually run on the GPU. Kernel is a function that can executed in parallel across many GPU threads. So let's take an example of vector add.cl. On the screen you are seeing a code. This is the basic how kernel look like. Let's understand this code. Here __ kernel marks the function as an OpenCL kernel. _global indicate global memory access between host and device. AB is the input and C is the output buffer. And get global ID, get the thread index. Each thread processes one element. If your array has 100 elements, 100 threads run in parallel, one for each addition. This is the power of parallel execution on GPU. Also note, unlike our C++ code, OpenCL kernel are compiled at runtime.
Before we can run any OpenCL kernel on the GPU, we need to set up a well-organized project. This helps keep our code clean, modular and easier to debug. Let's go over the first thing we need to do. First, we need to discover the OpenCL platform and device. We start by identifying which OpenCL platform are available on the system like Intel, AMD or NVIDIA. Then we pick a device from the selected platform, usually a GPU or CPU depending on what we want to run our kernel on. Second, we load the CL file from the disk, then we compile it during runtime using OpenCL APIs. These allow us to change the kernel code without recompiling the whole C++ project. Third, we set up memory and buffer. We allocate memory on the device and create a command queue. These queues handle sending commands like kernel execution or data transfer to the GPUs. Fourth is we launch the kernel on the device. Fifth, what we do, we organize code into modular file. To make the project scalable and reusable, we split the code into multiple files. Headers for declaration, source file for implementation, a separate folder for the kernel file. This improves readability and makes the code base easier to maintain. The project structure will look something like this. Let's see what all these files will do.
We should be aware of CMakeLists. This file is the brain of our build system. It instructs the compiler on how to compile the project. It specifies which source file to compile, where to find headers, compiler flags for optimization, debugging, and libraries tooling. Think of it as a blueprint of building a complete C++ and OpenCL application. The include folder. This folder contains header file.h that declare function without implementing them. Think of them as a blueprint. In previous video, we have understand what is device model and platform model. Device model.h declare function for querying GPU device into such as device name, memory size, compute unit, and OpenCL version. Platform model.h declare function for querying platform into including vendor detail, number of devices, and extension. These headers help us to inspect the OpenCL environment before running a kernel. Now on the source code folder, this is where the host side logic of the application lives. Main.cpp. The driver that set up OpenCL context, compile the kernel, manage memory and run the kernel. Device model.cpp implement device specific function declared in device model.h and platform model.cpp implement function declared in platform model.h. Together these source files handle everything from setting up OpenCL to invoking kernel on the GPU.